Hello and welcome back to another video. In this problem, we're asked to solve each equation for x. So in A, we have ln of x equals 1. So the first step is to turn this into a form where we can actually see the bases. So the natural log is log base e. So this is log base e of x is equal to 1. And here we use the relationship between exponentials and logarithms, which states that if b to the x equals y, then log base b of y equals x. So we can rearrange, depending on where our variable is, to solve for x, or to solve for y. We can rearrange it from an exponential to a logarithm. So here we want to get it to an exponential, so it becomes e to the 1, which is just e, equals log base e of x. And here we do that a second time. E to the power of e equals what was inside the logarithm, x. So therefore, this is our solution, e to the e. So that's A. B is going to be a little bit more complicated. So we have e to the ax equals c e to the bx. And the step that we're going to do that's really going to break this down is we're going to take the natural log of both sides. The natural log is a one-to-one function, which means that if the natural log of a value is equal to the natural log of a value, then those values must be equal. This is not true of something that isn't one-to-one, like x squared. If we had negative 2 equals 2, you can't just square them and say 4 is equal to 4. Therefore, negative 2 must be equal to 2. However, since it's one-to-one, we can say, take ln, which is log base e, of e to the ax is equal to log base e of c e to the bx. So if we have here a log base e of e to the some power, right? You can think of it as the exponential and the logarithm canceling each other out, and we're just left with a to ax. Same thing here, but we have a c in the way, so we have to get rid of that first. So if this is equal to log base e of c times e to the bx, this is equal to log base e of c plus log base e of e to the bx. If there's two things being multiplied within a logarithm, you can add their separate logarithms. So ax is equal to log base e is ln of c, plus, in a similar thing, we have the log base e of e to some value. The exponential and the logarithm cancel out, and this is just bx. Now we can actually solve for x. Subtract bx from both sides. Ax minus bx equals ln of c. Factor out an x. This is x times a minus b equals ln of c. Dividing by a minus b. This cancels. X is therefore equal to ln of c over a minus b. So solving these equations, a results in a solution x equals e to the e, and in b, it's x equals ln of c over a minus b.